Chapter 2, Research Methodology. Science has four primary goals. That is description, what a phenomenon is, prediction, when it will happen, control, to control what causes it to occur, and an explanation, why it occurs. Now we're going to move on and discuss a scientific method, but first, what is research and what is data? Research is a scientific process that involves the careful collection, analysis, and interpretation of data, and data is a collection of measurements gathered during the research process. To define scientific method, it is a systematic and dynamic procedure of observing and measuring phenomena used to achieve the goals in description, prediction, control, and explanation. It involves an interaction among research, theories, and hypotheses. The role of theory. A theory is a model of interconnected ideas or concepts that explains what is observed and makes predictions about future events. Theories are based on empirical evidence. A hypothesis is a specific, testable prediction, narrower than the theory it is based on. How can we decide whether a theory is good? When we talk about a good theory, we do not mean that it is good because it is supported by research findings. One key feature of a good theory is that it should be falsifiable. A good theory produces a wide variety of testable hypotheses, and good theories also tend towards simplicity. There are a variety of testable hypotheses. There's Jean Piaget's theory of infant and child development. It generated thousands of hypotheses in scientific papers. And on the end, there's Freud's theory that dreams served as wish fulfillment function, generated few testable hypotheses. The scientific method reflects a cyclical process. A theory is formulated based on evidence from many observations and refined based on hypothesis testing, scientific studies. From the theory, scientists derive one or more testable hypotheses. Scientists then conduct research to test that hypothesis, and the findings from research might prompt scientists to reevaluate and adjust the theory. A good theory evolves over time, and the result is an increasingly accurate model of some phenomenon. The scientific method tests hypotheses, and there are 7 steps. First, you have to frame a research question. Then you have to conduct a literature review. Then you form a hypothesis. You design a study to test that hypothesis, and then conduct it. You collect the data and analyze it and report the results. Here's a figure from the book that lays out the 7 steps of the scientific method. As I said, the scientific method is cyclical. Once the results of a research study are in, the researchers return to the original theory to evaluate the implications of the data. If the study was conducted competently, for example, used appropriate methods and data analysis to test the hypothesis, the data either supports the theory or suggests that the theory be modified or discarded. No single study can provide a definitive answer about any phenomenon. No theory would be discarded on the basis of one set of data either. Replication is important to research. It is the repetition of a research study to confirm the results. When the results from 2 or more studies are the same, or at least support the same conclusion, confidence increases in the findings. These important replications provide more powerful support because they rule out the possibility that some feature of the original setting may have contributed to the findings. Theory refinement. If you have multiple theories, you can design critical studies that directly contrast the theories to see which theory best explains the data. Evaluating scientific findings requires critical thinking. What do critical thinkers do? They question claims. They seek definitions for the parts of the claims and evaluate the claims by looking for well-supported evidence. Here's an example of a study. A group of adults for research study on driving. There are two tests: driving and talking on the phone, both in hand and hands-free, and driving and drinking to a 0.08 blood alcohol level. This is the usual legal limit. They established a baseline by having each person drive in the simulator without the phone or drinking. The results showed that a phone conversation led to delayed reaction to objects including brake lights and a greater number of rear enders. And drinking led to aggression, tailgating, and hard braking, but had fewer collisions. And this concludes Part 1 of Chapter 2.